there is a problem because tangent is sine over cosine. So the bottom cannot be 0. What makes the bottom 0? Cosine theta cannot be 0. What makes the bottom 0? We have this guy, and that tells you what makes the bottom 0. It tells you that this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. This is cosine, this is fine. So 0 degree is fine. 90 degree has a problem. 90 degree has a problem. This is fine. 270 degree has a problem. So what is it? 3 pi over 2? 3 pi over 2. Alright. So this, it cannot be that one. Cosine cannot be 90 degree. Cosine cannot be 270 degree. Look at that. How that work? Let's see. If you create a table, tangent theta is equal to sine theta over cosine theta, and the value. So this is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Do the opposite. Okay, you have 0, you have pi over 2, you have pi, 3 pi over 2, 2 pi, minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi. Okay, what is this one?
0.
Sine, yeah, because this is 0, right? Sine 0 is 0, 0 over 1 is 0. But this is good. This is good. Does that make sense? This one is bad. Something over 0, undefined. Undefined, UD, undefined. 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 Pi is good. Pi is good. Okay, good. Good or bad? Good or bad? That's what we are checking. 3 pi over 2. 3 pi over 2 bad? Undefined. Undefined. 2 pi. 2 pi is okay. What about the other one? No good? No good. The next one. Oh, undefined. Okay, yeah. Undefined. The next one?
0.
Is okay? The next one? Huh? Undefined. And next one? Good. Okay, so undefined term we call it asymptotes. So it is asymptotes at pi. It is asymptotes at pi over? Pi over 2. Pi over 2. So please draw it like that because you want to be doing a million times this. And 2. And then what else? Negative 2 pi. Negative 3 pi over 2. Negative 3 pi over 2. What do you call that? Vertical asymptotes, right. So these are the, how many vertical asymptotes? If I ask you how many vertical asymptotes, a paragraph of tangent from negative 2 pi to positive 2 pi, how many vertical asymptotes? Yes. 1, 2, 3, 4. Yes. Okay, great. Now,
based on what did you draw the vertical asymptote?
say it again.
Based on what did you get those for? Is it because it's independent?
Yes, because the bottom is 0. They make the bottom 0. They make the bottom 0. They make.
It's not defined.
They make the bottom 0. When bottom is 0, is not defined. Does that make sense? That's by convention. That's the essence of calculus. Calculus was born because to solve that type of problem. Yeah. Okay. So what are you gonna do? We're gonna approach. So this is tangent. Yeah. If someone asks you, what is the, yeah.
There's no cycle between 3 pi over 2 and 2 pi. I mean, there's no graph between 3 pi over 2 and 2 pi.
Yeah.
Oh, you have, why the half?
Yeah. And then the bottom. Yeah.
That means that that line passes through 0, but can cross to the other side.
It can, that, yeah, when you use the calculus, then we're gonna call it that the limit of tangent as theta approaches to pi over 2. The limit is what? Negative infinity, yeah. And it is, if you don't see that, then why negative infinity, you do not understand. If you see that, then it makes sense, because the arrow goes to negative infinity because it does not allow to touch the pi over 2. Okay, so this is tangent. Now we're going to solve those problems. Who is reading it?
A sine to two sine x.
Y is equal to number 3. Y is equal to
2 sine x.
2 sine x. Really? Skip that one.
Skip that.
Because you know how to do that. Agree?
Yeah.
Raise hand if you don't want to skip this one. Nobody raise hand, so we are allowed to skip this one. Number 4.
Technically, there's no 2.
Or 2 cosine.
You did that already.
2 cosine. Can we skip this one?
Yeah.
Nobody disagree. Okay. Number 5.
2 sine minus 1.
2 sine x minus 1. Okay, things looks better for you now. That's great. Because you quickly realize that we did those problems at the beginning. So now, here is a problem. The problem is we're gonna solve together, me and you. What's your name? No, him. The red shirt. What's your name, sir? Huh? Brandon. What is the upper limit? Upper limit is d plus a. What is our d? Minus 1. What is our a? Plus 2. So what is it? 1. Lower limit d minus a. What is our d? Minus 1. And what is our minus 2? And that is negative 3. Okay, we're gonna get used to it, okay? Alright, so now we're gonna do, this is sine, and we know that the parent equation of the sine is look like that. Nothing wrong to draw it at the side and erasing it later. And then we have to take care of some business, and the take care of some business is a negative 1. Negative 1. So negative 1. And that is our, this is, forget about this line now. This is like not so important now. Parent equation, this is important. This is not so, yes sir.
So like, let's say when you was doing 2 sine, so that would just like flip around.
Say it again.
Like when you was doing 2 sine.
2 sine.
Yeah. Well, like the negative 1 just flips the equation around.
Yes. If negative sign, okay, very good. If this is sine, what is the negative sign? So the orange one is y equal to negative sine x. And this one is y equal to sine x. Is that what you asked?
Yeah.
Does that make sense?
I mean, I'm understanding that like now you can start like that. How do you say that?
This negative and this negative is not the same thing.
I mean, but like.
This negative and this negative not same thing. How many of you think this negative and this negative is same thing? No, because this is amplitude. This is the function itself, and this is just the vertical shift. Does that make sense? This is the whole function itself. Does that make sense? Okay, now orange line is important. What is the upper limit?
1.
Upper limit is 1. So we're gonna write 1. 1. What is the lower limit? Negative 3 somewhere. 1, 2, 3. You don't have to be 100% precise and don't draw the line. Okay. Now, what is our period? What is our period? 2 pi, right? Yes, 2 pi, right? Okay. Then we are free to go. This is sine. Okay. Yes. We're gonna come
Why
here.
did you choose 2 pi the limit?
Say it again.
Why did you choose 2 pi?
Say it again. Yeah.
Two power of the meter.
Why we need this by that's what she's saying.
Oh, because B is. Does that make sense? Yeah. Okay. Good question. Yeah. Okay, I'm gonna do it like in slow motion.
Okay.
I hope this is. Okay, if that's the case, what are you gonna do? You just move it. Yeah.
So in this case, the amplitude doesn't matter, right? So we don't have to go to low amplitude.
That's how you find amplitude.
Yeah, so we have to just do in between the limit, right?
That's right. So amplitude become the lower amplitude and upper amplitude. Very good question. Okay. So this is -3. This is 1. So this is the upper amplitude. This is the lower amplitude. Amplitude when you my computer doesn't work. Okay. What is the amplitude right now of my conversation?
0.
Not 0. 1.
Conversation?
Yes, I am talking to you right now.
Yeah.
What is the amplitude of my conversation right now?
It depends on the
Like 200, say 200 decibel. 200 decibel.
Oh, wow.
All right, can you raise your hand right now? What is the amplitude of my, whatever I said a few seconds ago?
1,000.
Yeah, lot. We don't know how much, but a lot more. So that's give you an idea what amplitude is. When you listen to the radio, you change the amplitude. If you change the amplitude, you see that. Yeah.
Like the lower limit is -3, the upper limit is -1. Is 1.
Yes, it is.
Based on what did you found -1?
You see that here.
No, I understand that, but the -1.
The -1 is the vertical shift.
Huh?
Vertical shift with the function. What is the function? Read the function.
Okay.
Don't read it from here. It's here.
2 sine x
So that -1.
-1. Oh yeah.
If I make that orange, that's gonna make more sense. Ah. Orange.
Okay, so
Question.
Yes, sir.
press.
That -1. The thing that with the formula d plus 1 and d minus 1, is it gonna put where the thing touch, where it touch, where it comes up and where it comes down.
That gives you the amplitude. Upper amplitude and lower amplitude.
Which is the first number.
Amplitude is on the y-axis. That gives you amplitude, nothing else.
Professor,
Yes.
so the x here, if we do not have anything relative to x, that means we do not have a phase shift. Like in this question, this has a 0 phase shift. Okay, that's what I want to
This is a 0 phase shift.
Okay.
Because this has no B and C is 0. C is 0.
So D just give us the new or repair.
D gives us the starting point. D gives us the starting point.
It's like the how do you refer the reference of
The reference, okay, reference point. D gives you reference point. If you ask me, okay, jump off from the top of the table. That's the D. I have to jump off from the top of the table.
But, okay, so what distinguishes in this case? How you determine the difference between the C and the D in the absence of one or the other?
Oh, okay. All right. So if the problem, then problem would be, let's say 2 sine x,
Like put the
2 sine x, and then you can see like 3x plus 5 plus, this is always going to be in the parentheses. This one always going to be in the parentheses.
Oh.
This is always
So
going to be.
the vertical shift is always in the parentheses.
That's, no, the vertical
The
shift
vertical
is,
shift is outside.
yeah, phase shift
And the phase
is,
shift
yeah,
is in the
always
parentheses.
period and phase shift is
Alright.
always.
put the parentheses x and minus 1. He's gonna see the difference.
Oh,
Like-
okay.
No, x and minus
Oh,
1.
okay.
And this, no, the, close the parentheses after minus 1.
No, that's how it should be.
Yeah, it's different.
No, that's how it should be.
No,
No,
that's right.
that's how it should be, not like.
Yeah, to show him the difference.
No, that did not.
No, she's saying put the parentheses around the 1.
So
I
you can
cannot.
see-
No, no, no.
It's gonna give different equations. At that time, you don't have d, you just have.
No, putting parentheses,
It's gonna change.
putting
It was gonna change, it would be like x plus 2.
this would be,
Yeah,
Yes.
that's what I'm
No,
saying.
Okay, okay.
Just
She was
like-
saying to show us an example of it.
okay.
Yeah, but you change the
Yeah.
equation in this
Yeah.
space.
But I don't want to put a parenthesis inside negative 1. Well, can someone read the next one? Okay, those remaining problem of the homework, let's go back to the main thing. Okay, those remaining problem, I think you already got the hang of it. Those remaining thing of the homework, yeah.
What's gonna happen for cosec x?
Cosecant x. Okay, let's do that one. All right. Okay, we're gonna do the secant and cosecant. Okay, y is equal to secant x and y is okay. First, let's do the secant x. Okay, when you do secant x,
The second will be the same as minus second.
no.
1 over sine.
One over sine.
Okay, it's not 1 over sine. It's 1 over cosine x. Okay. It's gonna have asymptotes, yes. So 1 over cosine. The cosine is not allowed. Cosine cannot be
No, cannot be
0. What makes it 0? What makes cosine 0?
pi over 2 and 3 pi over 2.
Pi over 2.
3 pi over 2.
That's why you put it's an asymptote.
It will be the same at the time.
Okay, now.
All the sine, all the pi over 2 and 3 pi over 2 will be undefined.
All right, now. How the cosine look like? All right, so this is our asymptotes, right? So what is our okay? So let's draw the theta. Okay, so this is what? This is pi over
Over 2,
two. This is
pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi.
So 0 pi over 2 pi 3 pi over 2 2 pi negative pi over 2 negative pi negative 3 pi over 2. All right, tell me what happened when cosine is 0? Nothing happened. It's good.
Good.
It's good, right?
Yeah.
What happened when cosine is 90 degrees?
You see it.
Undefined, okay. What happened when cosine is
When
Negative.
x
Negative, okay, that's good, right? Negative, okay. What happened when, what about over here?
That's undefined.
Undefined?
Yes.
Here?
Wait, I can't see.
Yes.
What?
2 pi? 1?
So good.
Is it 1?
Yes.
Yes, positive,
It's
yeah.
on the.
Oh, okay. By the way, this is negative 1, right?
Yeah.
And this is 1.
Yeah.
What about here?
Undefined.
Undefined. What about here?
Negative 1.
Negative 1. What about here?
And
Undefined, okay. Alright, so this is 1 and this is negative 1. Alright, so this is cosine, so is it start from? Okay, so the first one is 0 is 1. The second one is problem.
So just.
The third one is minus 1. Just put a dot now. And the next one is a problem. Okay. The last one is 1. Put a dot. Take care of the dot later. Come back this way.
problem.
Problem. Next one is negative 1. Dot. The next one is problem, right? And the next one is dot on the top. Okay. Now first, what are we gonna do? We're just gonna close our eye. We're gonna draw a sine curve. We're just gonna close our eye. We're gonna draw a sine curve. We draw something to erase. Okay? We draw a sine. We draw a cosine curve. Okay? Now, no, I'm drawing it using same color. Sorry. There is something I see over here. Oh, this is the line.
That's
This is the line. Yeah. Okay, so here is here. Okay. What do you see?
You can do it at that top one, can you?
The top one,
That top
yeah.
one, you can do it.
This one?
Yeah.
Yes, very good.
And then
That's
at the top left and top left one. Yeah,
Top
half
left?
of one.
Top left.
Yeah, top left half of one.
Okay. So you draw like that and you erase that. That's what you mean?
Yes.
Okay.
And then the same thing on the other side.
You draw like that and you erase that.
Mhm.
Okay. What else you erase? I lost my final eraser.
It's because of 1 over cosine, right?
Yeah.
That's
So all the purple, everything else you disregard. And then when you do, this is going to be a very complicated. This is going to be very complicated. When you do take the complicated derivative, then this will really help.
Professor, if it's happened that we have a coefficient in front of 1 over cosine of x, we're going to consider that one just as an amplitude, right?
Amplitude.
Okay, that's it.
You're going to just change it from -1 to -3 or whatever.
Yeah.
And then okay.
Is equals 60 degrees. Is contained a circle with radius equal 30 inches. Find the living or result of term OP.
So find the arc length. Is that what it says? Find the arc length. Find what? Length of the arc. So find the arc length. So find the length of the arc. Length of arc. And then number 2 is find what?
Here we go.
Find the area. Alright. Length. Okay, so for the length, anybody, what is the circumference of a circle? What is the circumference of a circle? 2 pi r. What is the area of a circle? Pi r squared. Okay, great. We're gonna use this too. Now, which one we're gonna use for number 1? Okay, so let's call this A and let's call this B. Which equation should we use for 1? A or B? Okay, raise hand if you think this is B. No, nobody? Okay, that's good. That makes me good. Alright, so what are you gonna do? You're gonna write theta over 360 times 2 pi r. What is the theta? 60 over 60 times 2 pi times 30. So 60 over 360 is this. 6 goes to 36 6 times, and 6 goes to 35 times, so you have 10 pi. So 10 pi, length of arc is 10 pi.
Why you want to use formula
You can use anything you want.
instead? Why you don't use derivative? You're gonna keep the same, or it has to be like this?
No, we are not doing anything derivative here.
No, I mean just the formula theta r l.
Oh, if you take the, yeah, that's right, yeah. Okay, so find the area. What is it? Theta 360 times what? Pi r squared. So theta is 60 over 360 times pi 900, right? 60 goes to 360 how many times? 6 times. And 6 goes to 900. 150 exactly? Is it? 35 and 0. Is it? 150? Confirm. Verify. Okay. So 150 pi. 150 pi. Alright. Can I move to the next one? Yeah.
Why do you write theta over 360?
This is the formula, yes. This is the formula for arc length, and this is the formula for the, what is it? What do you call it? The area of the sector.
This is 10?
This is 150.
No, not the first one.
First one is 10 pi, yes. Who is reading next one? Next one is what? What is even next one? Next one, nobody would be able to read next one. Who? Huh? Oh.
Find the exact value of the area
And the perimeter
of the area of these.
Oh, 22.
Yeah, it says find the exact value of find the exact value of the area and perimeter of this right triangle.
It's on the reverse side.
Okay. All right. Okay. Okay. All right. So number.
Area of the sector. That's what it is.
Okay. All right. So
That's a very 60.
Professor,
now,
where is part B of what you just did?
say it again.
Part B you didn't do.
Part B. There is a part B.
No, the area of the circle.
Yeah. This is part B.
Oh, that's. Oh,
Yeah. Okay.
dreaming.
No, it's fine. All right.
Where are they?
Okay. So. All right. So this one is homework. Number 22 is homework. Number 23. Number 22 is homework. The homework is just reading it. Reading part is the most important. So reading and doing, because only God knows what is there, but I'll check it in the computer. I have it. Okay. Number 23. By the way, 22 is the homework. Okay. So 22 is the homework. 23. What is 23? Can someone read 23? Yeah.
So next Monday we don't have no class.
We don't have class next Monday.
Wednesday or Tuesday.
We don't have class Tuesday. We come back on Wednesday. Okay. We do not look at the syllabus. We do not have class Tuesday. Just don't class. We don't have class on Tuesday. No, don't come Tuesday. Look at the syllabus. No class on Tuesday. All right. So we're gonna see a week from today on Wednesday. Okay. So every time when there is a kind of CUNY mess up, like it follows that, then we will not have class. Because I am taking a doctoral class, few doctoral class at Columbia. So I cannot miss those classes. Okay. Say it again? My recommendation, if you have to get like B plus or better, B plus or better, yeah. You should never ask a professor to write a recommendation letter if you do not get a B or better. So I mean, there is nothing much to what I'm gonna write. He or she is a nice person. That will probably help you get into a CUNY college, but not Columbia. Yeah. So. There is no such thing as A plus. A plus, the CUNY, no, we don't. A, just A. A plus and A is same thing, yeah. But yeah, A plus maybe, yeah. A plus or A, yeah. Okay. So, but it is possible to get an A, but A in calculus is very good. In calculus is very good. Don't forget to send me that story. If you have to improve your grade or anything, toward the end of, or at least when we have 2 exams, and then you would know that what you have to do extra to improve your grade, then you probably have to write a story so that I can do something. But you have to honor your grade. You have to show me the effort. Okay, let's go back. Where are we at now?
23.
23. Okay.
Verify
23.
the following trigonometric identities: cosecant of theta, tangent of theta, and cosine equal 1.
Okay. Cosecant of theta, tangent theta, and cosine theta is equal to 1. Okay, I give you 1 minute and solve it. Okay, now. Alright, now left hand side must be equal to right hand side. Can we start solving right hand side? No, because right hand side is the most simplified. If we start solving right hand side, we cannot even move. What am I gonna do with 1? Nothing. So leave it alone. We're gonna make left hand side just like right hand side. Cosecant is what? 1 over sine theta. Tangent is and cosine theta, leave it alone. You're just going to use common sense. What you leave it alone and what you don't leave it alone, depending on your thinking. Sine and sine cancel, cosine cancel, you have 1 is equal to 1. Can someone read the, can I erase it? Yes. Oh, okay. So that one was kind of sweet. The next one, who is reading the next one? When you read loud. I know that.
Cosecant theta minus sine theta equal cotangent of theta cosine.
Say it again.
Cosecant theta minus sine theta equals cotangent theta cosine.
Did I write it correctly? Yes. Please check it twice. If I write it correctly, then that's fine. Okay, great. I give you 1 minute. Then you stop. Cosecant theta. What is cosecant theta to us? 1 over sine theta minus sine theta. What is cotangent theta? Let's leave it like that for now. Okay. So sine theta. What is this one?
1 minus sine, 1 is cosine.
1 is sine square, right? So 1 minus sine square is by sine square plus cosine square is 1. So then cosine square is 1 minus sine square. So by this, we can, by the Pythagorean theorem, we can get cosine square theta over sine theta. Okay, now what is the cotangent? What is the tangent is sine over cosine. The cosine over sine theta times cosine theta. Cosine theta plus cosine theta times cosine theta is cosine square theta over sine theta. And now they look same. Use star. Raise hand if you got this right. You, and you kind of half. What does that mean? You got right this one, right? You didn't do this one. This one? So, this is Pythagorean theorem. A square plus b square is c square, so sine square plus cosine square is 1. Probably someday I will prove that. Then cosine is equal to 1 minus, if you send it to the other side, become minus, plus become minus. Does that make sense? Okay. Next one. It kind of makes you comfortable playing with trigonometric identities. 24. Not 24. What is it? C. What is it? Can someone read it loud?
Tangent square theta plus 1 equal to sec square theta.
Tangent square theta
Plus 1
plus 1
equal to secant square theta.
secant square theta. 1 minute. Right. What do you got right? Tangent square is what? And then what?
Sine square plus cos square theta equal to 1 divided by
We used the Pythagorean theorem like second ago, right? So this is 1 over and 1 over cosine square theta. 1 over cosine is secant, and 1 over cosine square is secant square. Oh, yeah, when you take the derivative of tangent, and you're gonna get secant. You're gonna prove that when you by the y equal to tangent theta. So if you take the derivative of this one, you're gonna get a secant. But anyway, where is mine? Okay, what is it? 1 over cosine square theta is what? Secant square theta is equal to secant square theta.
I don't know what happened here,
Yes, sir.
but I have other thing where is the same both sides, but it's other thing have -1 money equals -1.
Yes. Okay.
But you can like move them from time to time. It doesn't matter.
You can do, as long as you do the legal thing, that's fine. Yeah. Okay. The next one. Who is reading next one? Yeah, please. What number is it?
23b.
Okay. 23 D. Okay. Before I forget it. Okay. 23 D. D is what?
Cos square theta minus sin square theta is equal to.
Say it again.
Cos square theta
Cosine square theta minus
sine square theta
sine square theta
equal to
1
minus tan square theta
1 minus tangent square theta
over 1 plus tangent square.
1 plus tangent square theta. Okay, enjoy the. What is this one? And what is the other one?
45.
Altogether
45.
45.
What is this guy?
one is 175.
What is this guy?
Unknown.
All right. What is the balloon?
145.
This does not look like a balloon. One what?
This is like,
This is a cake. I saw a balloon like that, so that's fine. Yeah. Okay. So tangent. So tangent 30 degree is what? The tangent 30 degree is Jason over. No, opposite of what? Opposite of what? Jason. And then again, tangent 30 degree is tangent 45 degree is opposite of what? Jason. Okay, so we are trying to find x. X is what? 125 tangent 30 degree. And x is what? 125 tangent 45 degree. So 125 tangent 45 degree minus 125 tangent 30 degree, and this is the answer. Okay. When you do the related rate problem, you're going to see that again, but we're going to use calculus. But understanding and graphing is most important than the solving. Graphing part is more important. Solving part is easy. Okay. Now we're going to solve the last one, and I actually wanted to let you go if the next one is not last one. But since the next one is the last one, we always can wait extra 2 minutes, right? Yes. Okay. So we finished everything. Okay. Great. Sure. Okay. Erasing? Can I?
Yes.
Okay. Now next one. Thank you for reading that long problem. Who is willing to read the last one? Reading last one is kind of a good thing.
Yeah, I do it.
Who did not do before? You read like 10 problems.
Okay.
Who did not read anything? You did not read anything. Okay, go ahead please. This is the last one, whatever number it is.
State trooper is 930 feet from a straight highway with a speed limit of 65 miles per hour. 1 second after a truck passes, the angle theta between the highway and the line of observation from the patrol car to the truck is measured. If theta is 15 degrees, does the truck driver get a speeding ticket? 1 mile equals 5,280 feet. If theta equals 30 degrees, does the truck driver get a speeding ticket?
Okay, that reminds you the speed limit sign you saw before, right? This time, what is the speed limit? 65 miles per hour. He is not allowed to drive faster than 65 miles per hour, right? How far away the cop from the driver? 30 feet. Does that geometry make sense? Yes? No. Raise hand if this geometry, you can translate this geometry from the, yeah.
Wait, the 30 is it the 30 at the bottom, not the side?
Alright, okay. Let's make it, so the graph doesn't make sense, so let's do the diagram. Okay, now this is a truck, draw a truck. 30 feet or meter? Feet.
30 feet.
30 feet away the cops is hiding. Cops is hiding here.
Right.
Alright. I want to draw kind of like a nice car. A nice car. Like this. And this is NYPD. Okay. So this is the truck. This is the track, this is the NYPD, and this is 30 meters. 30 feet. 30 feet away the cop is hiding. Does that make sense? He is moving fast, right? At 1 second, how much he moved?
25.
We don't know. We'll find out. But cop is 30 feet away, right? That makes sense, right? At 1 second later, the cop looking here or cop looking here? Cop looking over there because the truck is no longer here. The car is, some point car will be here. This is two part. The cop will not be able to catch the truck. So probably we think the truck is here instead of truck is over here. Does that make sense? But even though over there, the cop knows how to do their business. Okay. Does that make sense?
Yeah.
So this is what degree? 15? 15 degree. Let's do the first one, 15 degree. By the way, if the angle increases, that means the possibility of driver breaking the law is decreases. If angle decreases, for example, if angle is 2 degree, then for sure the driver is spinning. Driver is moving very faster than maybe 200 miles per hour. Does that make sense? With 2 degree, maybe 200 miles per hour. We can even find it out. But 15 degree, the possibility driver breaking it is there, but it's not high. Okay, let's find it. But the other one is what? What degree? 30 degree. I don't think 30 degree break the law. Okay, let's find this one. All right. From this one, what I did is the other one is homework. 30 degrees homework. Forget about 30 degree today. 30 degrees homework. 15 degree. I put by geometry. I put this 30 on the other side. Does that make sense? Make sense? Okay. All right. So now go ahead. So tangent 15 degree is what? This x is this x. Does that make sense? So tangent is how much? Opposite over x. So x tangent 15 degree is how much? 30. So x is how much? 30 over tangent 15. Now there are lots of work to do here. So I want you to tell me what is 30 over tangent 15 is. Tangent 15 is 0.27 something, I don't know. Find it out. By the way, you need to have calculator for calculus. So x is 30 over how much? Point what? Point something. No, not point 10. Not point 10. Point?
0.267.
I think so. 0.267, but I don't know. Probably that's correct. 30 divided by 0.267 is how much? Is 112.359. 111. Okay, so 111. Okay, 111 is fine. We can ignore the fraction. Okay. 112 you said?
Yeah.
112. Okay, 112 is good. 112. Now tell me what to do. Did he break the law? We don't know. We don't know. This is not mile per hour. This is what? Feet per second. It's not the same thing. It's apple and orange. You don't know. You have to convert it to what? Mile per hour. So let's convert it. Don't. Okay. Huh?
Professor,
Yeah.
what determined that 112 is feet per second?
It's in the problem. In the problem. This is feet. This is feet.
Yeah.
Okay, so they mix it up.
And
This is feet.
Okay.
Yeah.
In time and seconds. Okay.
Yeah. We could have convert this one to mile at the beginning.
Okay.
Does that make sense? We did not. So we have to convert it right now.
We can bring up a conversion factor. 120.
Okay, so what is that? So 112 feet per second times. Let's make the feet to the mile.
But 1 mile over 520.
1 mile is 5 to
80 feet.
not 8. 5 to 80
80 feet.
feet times. Is that it, or we have to do something else?
Yes.
What?
Hours.
Hours. Thank you. Hours. Should it be in second or should it be in hour? It should be in hour, but we solve it in second.
Yeah.
So
Hours.
second must cancel. So 3600 second is how many hour? 1 hour. Second cancel. Feet cancel. 112 times 3600 over what? 5280. On the top, what do you have? Mile. On the bottom, what do you have? Hour. What is that?
76.36.
He barely broke the law. 76 mile per hour. Okay. So 76 mile per hour. So did he break the law? Yes, he broke the law. Okay. Now you're gonna do the other part as homework. So let's repeat the homework and let's go home. What is the homework? From the worksheet 6, 7, 10, 12, and then the problem is impossible to read. Read that problem, and then what is this part? This is what problem? 25, right?
No, it's not. You can read it.
25.
Okay, read it.
Is it 24? Oh, 24. 24B.